let's talk a little bit more about the distributive property. So the example that I like to go through is about getting lunch. And so suppose that hot dogs cost, let's say, $3, and then a soda costs $1. And so a meal is going to be a hot dog with a soda. Okay, so the meal is the hot dog with the soda. And so we probably went through a similar example, if not the same thing before. And so one way to do it would be to add the two together and then multiply it by however many people we're taking. So let's suppose that we're buying for five people. And so we could do 3 plus 1 times 5, or we could look at individually how many hot dogs and the cost, and also how many sodas and the cost. Right? So it doesn't matter which way you do it, it should be the same. So this kind of demonstrates distributive property, and it's a natural thing. So when you give this example, there are going to be some students who add it up first and then multiply by 5, and there's going to be other students who will think about it individually and how much of each they need. And so this could come up easily through a discussion piece instead of saying, this is a distributive property, it's A times B plus C equals AB plus AC. And it means a lot more when they come up with things rather than us feeding it to them, right? And the style of learning. So with that, let's revisit 103. So if we have two polynomials, and for our sake, we're just going to do the same one, we need to multiply, right? So we could use distributive property and group this together. So this could be one thing, and then distribute this entire thing to x and then to y. So it could be x plus y times x, and then x plus y times y. And then we could go through and then do a distributive property again, because multiplication of the order doesn't matter. So it can be on either side and you still distribute. So we get x squared plus xy plus xy plus y squared. And then you combine the like terms. So these two are like, so we get x squared plus 2xy plus y squared. But that's not the only way. So one of the methods that maybe, hopefully, you've seen in 103 is the box method, or you can call it the area method, right? So for this one, it's x times x, which is x squared. This one is xy. This one is also xy, and this one is y squared. Once again, all the calculations are exactly the same, and then you just have to combine the like terms and you'll get to this result. So the process is not what truly dictates if you're doing it correctly or not. There's multiple processes that you could take to get to the same result. But so we can see it as distributive property applied twice and then combining the like terms, or you can do the area model to see how that works out.